Good day, everybody. Welcome to Integrating Automated Testing into DevOps, an introduction. My name is Jeff Payne. I'm from Coveris. I'm going to be the speaker for today. So this is an introduction to a one-day class that I'll be giving at the upcoming International Conference on Software Quality and Test Management that will be held from May 31st to June 5th. This class is on June 1st. Hoping you all will attend. But there's a lot of great tutorials and track talks going on during this excellent conference that will be held at the Falls Church Marriott, Fairview Park. This presentation is being recorded. It is for those who have registered for this webinar, and all material is copyright, so please do not distribute this information to others outside of webinar participants. If you could also hold questions until the end, I'm going to try to leave a little bit of time so I can answer questions. There is a questions box on your GoToWebinar controls that will allow you to answer or to ask questions that I can then answer at the end. So just a little bit about myself. I've been building and testing software for about 25 years. I've run a couple of different softwares. We focus on agile development, and just to set the context, when you're doing agile and you're doing it down in the trenches and doing the engineering things that you're going to need to do in test software, you can't avoid DevOps. It's an integral part of the development and then delivery process for your applications, and so we've been doing DevOps for a long time. What I'm going to talk about today is how you should think through integrating test automation into that process, and also doing a little bit to introduce you to what DevOps really is, because a lot of people don't really understand it. And then we'll talk about, after that, how do you go about integrating test automation into various pieces of it. In this talk, we're going to focus on continuous integration and continuous delivery. So what is DevOps? So DevOps really is not a tool. It's not a particular methodology. It's an approach and a philosophy to get everybody involved in the software development and delivery and maintenance and operation supply chain, if you will, all collaborating and communicating and talking together. There are good tools to help support a DevOps process, and there's good practices and methods as well. We'll talk about some of those, but fundamentally it's about getting everybody talking and getting everybody in sync. Some of the processes and tools that you'll hear about, and I'm going to cover some of these today. In the one-day course, we go into much more detail in all of these areas. First, let's talk about the processes. You'll hear people talk about a DevOps pipeline or a DevOps process. And what that really is just the movement of your application from the developer's desktop, where it's being developed and built, through a testing process and into production, where it's maintained and supported for use by customers. So that process, that pipeline, if you will, and all the feedback loops that happen when something in that process goes, is a critical DevOps process that you have to get right. Second is, as mentioned, you can't really do DevOps successfully unless you've integrated it into your sprints and your in your iterations in a continuous manner. And so how you do that and how it interacts with development and test that's done in your sprints is a critical process that you have to get right. And last but not least, out of every step in this process is going to come some artifact. It might be code, it might be tests, it might be built applications, it might be scripts or other things that get created, it might be gates that we check quality at to make sure we're building a product that is of the acceptable quality for our customers. Whatever those things are, there's a set of those things that have to be understood, have to be defined, and there has to be specific responsibilities for people to use those artifacts during the entire process of pushing our code out to production. As mentioned, there's also a bunch of tools that you can leverage and use. Tools to manage and automate your builds, tools to manage and automate your tests, tools to provision and configure environments, whether they're virtual, whether they're physical, whether they're out in the public cloud, whether they're in the private cloud, no matter. There's tools available to help that process and automate some of that process. And then last but not least, there's tools to do what we call orchestration, which is really push code and the applications built from code down through the process and make sure that every step of the way we're setting up the right environments and we're putting the right code and applications on those environments and we're using the right testing capabilities to make sure that our code works. So fundamentally, what DevOps is trying to solve is what I like to call the DevOps versus Ops conflict. Software development and test is all about understanding that customers want value, right? They want as much value and enhancements and functionality as they can possibly get. And so in software development, there's always a need for change. We have a desire to rapidly roll out more value to customers. Customers often, at least when they're looking at their applications, care a lot more about getting new functionality than they do about weighing really the risk that that new functionality might bring to them. And so, development is focused on creating new features, modifying and enhancing existing features, and fixing bugs and getting those out as fast as possible to make customers happy. On the operational side of things, it's exactly the opposite. In operations, we want to make sure we have a stable production system. It's reliable, it's available, it's secure, it gives acceptable response times. If we have service level agreements, also known as SLAs, with our customers, that we meet those and aren't penalized for not meeting those. And so there's really a fear of change for very good reasons. We don't want things to change in a way that's going to potentially impact some of the stability of what we have in production. This push and pull between development and ops causes all sorts of conflicts. It causes quality problems. It causes agility problems. And those things are things that DevOps is trying to figure out how to address. So what are some of these challenges that we see? These are probably some things that you've heard or that you are aware of regardless of where you are in the development, test, deployment, operations process. The first is the statement, well, the code compiles, therefore it works, right? I'm a software developer, and I write some new code, and I compile it, and it compiled, so I declare victory. And of course, we get downstream, and we find out, well, while syntactically it might work, it doesn't do what the customer wanted it to do. The second challenge is what we call Big Bang integration. That is where we've got a large team and we wait until very late in the software development life cycle to actually try to integrate code and get it all working together. This is a very dangerous thing from a quality and an agility perspective because typically those integration points are points of confusion and misunderstanding between people who are building and testing particular components or pieces of the application. And when we try to integrate things and do that all at the end, it can cause significant delays and quality challenges for our application. A great example is we were working with a customer a while back, and they were using a traditional software development process, and after almost a year of development work, they tried to integrate together all of the disparate components that have been built, albeit supposedly against a defined, well-known architecture. And they had allocated a couple of weeks to get everything integrated and a final system test done. As you can imagine, that was not enough time at all. We'd advised them that it wasn't, and it actually took almost 6 months to get through that integration process. That's something you don't want to have to do when you're building software. The third is throwing software over the fence. So, one of the challenges in testing is in QA and traditional methods and approaches is we often get code very late in the life cycle, and testing cycles are crunched, and we haven't seen it before. And so there's no iteration or tight feedback loop with the developers, and bugs are found very late in the life cycle where they're very costly to correct and often blows our budgets and our schedules. The fourth is the standard, well, it worked on my machine. I don't know why this code doesn't work in that QA environment or that staging environment. It worked on my machine. I don't know why it doesn't work somewhere else. How many times have we heard that, right? We hear that all the time from development or test when something downstream doesn't work as it did in a particular environment that was tried earlier. And then last but not least, you often hear from operations, yeah, we'll get you a new QA environment if that's what you need, but we'll probably have that up and ready for you by 2016, right? We don't often get the responsiveness we need in getting the environment set up that we need to do the job at hand when we're in a complex, large software development and test effort. DevOps is trying to fix a lot of these problems. So let's talk about how it does that and how automation of test is so critical to that process. I thought I'd start by giving you an example of what a DevOps architecture looks like. Now, one point of caution is the actual architecture that you're going to use to do DevOps for your particular organization, your particular product, your particular platforms, your particular process is going to be different. There's no, as I mentioned, one way you do DevOps and one template you can follow, because it's going to depend on the types of testing you need to do, the types of compliance you need to do, the environments you have, whether they can be automated, how much they can be automated, et cetera, et cetera. But I thought I'd give you an idea of how it typically works. And then we're going to step through two use cases. Continuous integration use case and a continuous delivery use case, and talk about how testing fits into those use cases and how we leverage automation from a testing perspective. So I've got on this slide some numbers. I'm just going to walk through each number for this particular application to give you an idea of how DevOps is utilized in a true environment. So step number one, we've got in the middle of the diagram to the left a developer workstation. The developer is working on a new function, commits that code into a source code repository. In this case, we're using Git. And when that code gets checked in, when it gets modified, on a regular basis, usually, say every minute, Git is pulled by what's called a continuous integration server. In this case, it's the box in the lower left called Jenkins, and it pulls looking for changes to the code. When it finds changes to the code, it pulls that code out, and it does a local compile. It does some local static analysis checks, some unit tests, some other types of things to make sure that the commit is valid. And we'll talk about later what happens if it's not a valid commit. So that's number two. Assuming that that works and the code compiled and the test is passed and we're ready to move on, then we typically push what we compiled into a repository that will allow downstream environments who want that particular application, piece of the application, to be able to go ahead and access it and utilize it. And that's step number three. At the same time, step number four, Jenkins, the continuous integration server, in this instance, goes over and talks to what's called the puppet master. We're using in this example a piece of software called Puppet to do our automated provisioning and setting up of machines downstream. So Jenkins calls Puppet, tells Puppet that it wants a new environment set up. Puppet has a set of scripts that it then pulls from Git that tell it for the environment that's been requested what to set up, how to set it up, how to provision it, how to configure it, and what to put on it. And that then is executed by a set of boxes. These might again be virtual, they might be in the cloud, they might be wherever, to set up that environment. That's step number 5, and pull the application that's been built out of the repository, step number 6, and put it in the appropriate places on the boxes that we want to do some sort of testing. Now, step 7, then Jenkins fires up and starts, in this case Selenium, to then run some tests associated with that environment and the application that's been set up to do whatever we've determined needs to be done from a testing perspective on this particular environment that we have. And the results of that testing come back to our continuous integration server, Jenkins, number 8, so we can see if those tests passed. Now I'm showing a series of environments here, one called DevInt, then QA, then staging, then production, to give you the concept that once you set this up, you can do this loop that I just went through, not just for a single environment, but then push it downstream and do exactly the same types of activities in further environments, doing different types of testing that are appropriate on those particular environments. And so this isn't a one environment test, but a series of tests on a series of machines based upon what you're trying to accomplish from your testing perspective before you get to production. So let's talk a little bit about how that actually works in practice and how tools fit into that. We'll start with continuous integration. So you've probably heard the term. If you're not totally familiar with it, continuous integration is the practice of continually building, testing, and integrating your software to identify defects earlier in the process. This is to combat the challenges that I mentioned earlier around assuming since something compiled it works, not knowing whether code is going to work on environments that are downstream, and basically not conforming to any quality checks or other things that we've put into the process that we want to make sure work. Test automation at this level typically needs to be the type of testing we can do rapidly enough to give feedback to the developers every time they commit code. As I showed in my last example, every time a developer commits code, and if you're doing continuous integration properly, developers are committing code very regularly. We're talking many, many times a day is this process being run. This is not something that's being run once a day or once a week in our process. Now, a good developer that's used to doing continuous integration will type along and hit check-in, type along and hit check-in, type along and hit check-in. They'll get used to doing this really continuously. And every single time that happens, up fires Jenkins, our continuous integration server, and we check whether what they put in compiled and it works at some level. We'll talk about what types of testing you typically do for this in a second. But you want it to be rapid feedback. If the developer checks something in and they don't find out till tomorrow that what they checked didn't compile, or that their unit tests didn't pass, or that some sort of metrics around the quality of their code or the security of their code violates the definition of done and whatever we've defined as being the important quality objectives for check-in, that's not fast enough because they're onto other things by then and may have to even rewind to figure out where they were to fix whatever problem was there. And so it has to be rapid. All right. Typically as well, because we want to make sure that that code is going to work downstream and that we're going to be able to integrate these changes into other code that others are changing, we're going to want to integrate that code with other changes that have been done recently by other developers, and we're going to want to push that code downstream through the environments that we have, and also just make sure the application comes up, it passes simple smoke tests, and that there's nothing funky about the application and the environment that's been set up and all the tools that are going to be needed to do more rigorous testing on, say, our QA environment. So we want that feedback as well, and that's feedback we want very rapidly. Now, as you can imagine, based upon the size and complexity of the testing process that you have and the amount of testing that you need to do and how much automation you have in place, it's typically necessary to split the types of testing you'd want to do for continuous integration into what I'll call check-in tests and nightly build tests. Check-in tests are those tests that are going to give you feedback very rapidly to let the developer know whether what they've done has broken something. Nightly builds typically run a more rigorous regression testing across an integrated set of changes that have been made during the day and provide daily feedback on the integration of new functionality that we can't run fast enough to give immediate feedback to the developers. So let's step through the process of doing continuous integration. So upon code check-in to a source code repository like Git or Subversion or any other one that you prefer, there's a set of quality checks and tests that we're typically going to do as part of our check-in build. All right, in Agile, all code should be unit tested. Unit testing, as formally defined, means the testing of functionality in isolation. So this is not a subsystem test on a component. It's not a test of a story. It's not a test of larger integrated components. It is an individual unit, an individual function, or at worst case an object that's been modified to make sure that unit works by itself in isolation. These tests are inherently automated. In fact, these tests are typically written by development because they're right in the code. If it's Java, they might be using JUnit. If it's .NET, it might be NUnit. There's a lot of unit testing frameworks out there that provide capability to do unit testing. If any of your development teams are telling you that they can't use tools to do unit testing, you should be skeptical. Yes, there are some difficult languages and difficult environments in which it's a little bit more, it's a little harder, but there are pretty good tools out there to do unit testing. Now, when you run unit tests, we want to see whether they passed, obviously, but we also want to know how good they are. And so one of the concepts you're going to hear a lot about in DevOps, and I talk a lot about it in the course, is what we call quality gates. And quality gates are those quality checks and those quality thresholds that need to be passed to move on to the next environment in our process. In CI, we use this to give the developer early feedback on how we're doing. When we get to continuous delivery, which we'll talk about next, we're really going to use that as a criteria for whether we're going to allow an application to move downstream in the pipeline of environments toward production. And if we're not passing our quality gates, then the application is not allowed to move forward because we want to make sure it assures and it meets the quality objectives that we have for the code. And so at this level, we typically use code coverage as a metric to validate whether the unit tests are adequate or not. Now, code coverage isn't a perfect metric. There's no perfect metric out there, but it at least lets you know whether the unit tests that have been created for a particular unit exercise all of the code. And it's difficult to argue that a line of code has been adequately tested if it's never even been executed by a test. And so code coverage gives us a good metric for whether our unit testing is sufficient or not. Is it perfect? No. But it helps make sure we've got a measure in place that our unit tests at least cover and execute our code. So we typically collect coverage metrics, and one of our quality gates on whether we're going to tell the developer their code passed or failed and can be used downstream or not for a candidate release is whether enough of the code is covered. In addition, at this level, it's very typical to run static code analysis, both from a quality perspective and a security perspective, to see if we can identify quality and security bugs that are resident in the code itself. And there are some good tools out there for doing this as part of your builds. And in fact, there's some plugins to Jenkins that do a lot of this work for you, and also let you set thresholds so you can be watching the quality of the code that's being produced and determining whether it's good enough to move forward. You can trend that data and show it in dashboards to obviously see whether your quality is going up, your quality is going down. Are you making progress working toward your quality goals before you release this code? As I mentioned, near real-time feedback is the key in this step. This has to be fast, and so you have to be very judicious about what you do and don't do as part of step one of continuous integration. Step two in the process. If the code successfully compiles and the unit tests pass and we deem the quality measures to be acceptable, we're going to want to take the modified code and integrate it into an integrated build with the rest of the application that has been checked in and has similarly passed its unit tests and quality measures as well. Oftentimes, once we do that, we run a regression test on an environment that you'll often hear called DevInt. Stands for Development Integration, right? This is where we, for the first time, are fully integrating the application, and we're trying to run regression tests to assure that anything that's been changed isn't breaking something else in the application in the process. Now, in terms of testing specific stories, which really sit between the units that we develop and the fully integrated application that we have here, you can do some story testing in step one, assuming you have enough time to do that for the particular stories associated with the units that you have. That'll give you really an integration test of the unit within the functionality of a story. You can also do more extended regression testing if you've automated your story tests at DevInt to make sure that your stories aren't breaking other stories that in between developers in an integrated manner. There's also additional security and quality metrics that can be collected at the DevInt level to really assure end-to-end issues do not exist. So for instance, at the unit level, you can tell whether, for instance, a particular variable is dead in a line of code as per that unit. But what you can't tell is from a system perspective whether some of the other variables who aren't dead in the unit are actually dead for the entire application, or whether security vulnerabilities that appear in a unit or potential vulnerabilities appear in a unit actually could propagate out and impact anything that you would care about at the system level. So you run additional security and quality metrics here, and you have quality gates and thoughts about how much of that is necessary and useful to pass that quality gate. Once you've successfully gone through that process, we typically package up this application that's passed its tests, and we store it in a repository. In my example, I was using Nexus. We tag it and version control it so that we have a unique number for that particular run, and we store it somewhere that will allow us downstream to use it to do additional testing as we see fit when we get to continuous delivery, which we'll talk about in a bit. The third step in continuous integration is pushing the application that's been integrated downstream to all the environments. We typically do this regardless of whether all the tests pass in step 2 or not. And the reason is that we're going to feed back that information to the development team and the test team as to what tests didn't work when we integrated everything together. But we'd like to still smoke test the downstream environments to make sure that the application will at least stand up and will operate in a basic way in the environment that is downstream that we're going to later do more rigorous testing on. A lot of times what happens is somebody makes a change to the environment. Maybe they update the operating system, maybe they reconfigure something, maybe they change out some of the hardware, and they don't tell anybody. And if we wait until we get to that environment, say we're in the staging environment, and now we're going to do the types of testing that we want to do in staging before moving to production, if we find out then that the environment isn't configured and set up properly, and we've coded to something that doesn't work, we're going to have rework later on in the process that we want to avoid. So we want to push downstream to all the environments we have access to and smoke test the application within those environments to see whether, as a system, that environment and the apps hold up and they work. All right? Now, this process from a continuous integration perspective really only works well if you can automate the provisioning and setup and configuring of your downstream environments. It doesn't need to be in the cloud, but if you can leverage virtualization to set things up quickly in an automated manner and tear them down quickly, you're going to be able to do this as part of your continuous integration process and give the developers feedback. If you can't do that, you're in an embedded environment, or you're in a situation where you really don't have access to any sort of private or public cloud services that you can utilize, or you can't figure out how for the environments you have to do that stuff, those are going to be things that unfortunately you're not going to be able to do on a real-time basis to provide feedback as part of continuous integration. You're going to have to wait till you get downstream a little bit to do that testing a little later. All of the results, regardless of everything we do in step 2 and step 3, get fed back to the Jenkins server. They get displayed in dashboards around quality, and all of that goes back to the development team, both the developers and the testers in our sprints, so that they know what works and what didn't and can address any issues early in the process. So that's the continuous integration use case of a DevOps pipeline. That's where you're trying to get early, fast feedback on the quality of the code you have at the unit level, the story level, the integration and system level, on as many of the downstream environments that you're going to have to operate properly on before you release. And again, we want that to be fast, quick, rapid feedback, as much of that being real-time as possible, some of it maybe being nightly, but we want to really push to make it as fast as possible so we identify and fix problems quicker and it costs us less to do so. The second use case is what's typically called continuous delivery. And this is the practice of continually delivering new functionality downstream and maybe even into production. That's called continuous deployment. You'll see those two sometimes used interchangeably, but continuous deployment really is focused on, continually deploying out to production. I will tell you that most organizations don't automatically or continuously deploy because of some of the hoops and hurdles that must be gone through to get something into production, and also because oftentimes for large critical systems, our customers can't consume new product every hour, every day, every week. We have to better structure our releases. There's training, there's other things that need to be done for our users and our customer service before we're ready to give them new functionality. But we can continuously deliver, which means push code through the process and automate as much of that process as possible so our QA and our testing during downstream environments is as easy and seamless as it can be. Essentially, what we're doing differently on the downstream environments than what we're doing in continuous integration is we're doing all the traditional testing activities on the various environments that we've set up in a rigorous fashion. Now, this could be automated, it could be manual, it's often both, right? It depends on the environment, it depends on what type of testing we're doing, and it depends on the capabilities of the team. So the more you can automate it, the more continuous your continuous delivery pipeline is. But oftentimes it's not going to be completely automated based upon the factors that I mentioned earlier. We're going to use quality gates in a continuous delivery use case to really prohibit promotion of code to new environments until it passes its quality requirements at a given environment. All right, if we're in a test QA environment and we have a set of functional tests that need to pass and acceptance of those tests to be done before we go to staging, for instance, and maybe that's where we do performance and red team security testing and other things, then we'll define a quality gate as to how much testing needs to be done, what's the definition of acceptable quality, and what is the gate that has to be overcome for us to push the button and promote this code up to the next environment for testing. As you would imagine, the further downstream we go, the more rigorous the quality gates are becoming, because we're essentially adding capability and adding various types of gates to the process as we get closer and closer to production. So what are the steps in this process? How does this typically work? Okay, this typically fires up and starts after the application has successfully passed the DevInt quality gate. Remember, DevInt is where we, for the first time, are integrating the application end to end. Once we have what we call a release candidate, something that has passed the DevInt quality gate and has been put into a repository and it's tagged with a particular version number and release, that can be picked up by anyone who's responsible for working at the next environment level to do whatever needs to be done. And the good news about storing these types of candidates that are happening all the time if we're doing continuous integration properly is that we're tagging them and version controlling them so that we're not clobbering the downstream testing activities. I mean, how many times have you been involved in an activity where you're testing something and it changes out from underneath you? That happens all the time in some of the places that we go into, and we have to help try to figure out how to fix that. Continuous or DevOps is only going to work with continuous delivery if you're properly version controlling and tracking releases so that you know you're testing on something that's not going to change out from under you. As I mentioned, the amount of automation that you can do during your continuous delivery process depends a lot on how much automation you can do for your testing, based on your environments, how much of the environment setup can be automated, and are there ways to leverage the cloud or virtualization to set up things that are outside of the physical space that you can operate within. You know, this resonates with me from a testing perspective because one of the things that I've always been a big advocate of is we spend a lot of time in software development and test trying to automate the execution of our tests, right? That's what tools like Selenium and you know, other tools do for us, is they allow us to automate the running of the test. For a lot of our environments, though, and a lot of our large-scale data-intensive applications, the real challenges aren't the running of the test. It's the setup of the data, the setup of the environment, it's the tear down of the environment, it's the processing of the test results. You know, I've gone into organizations where, you know, they're spending 80% of their time in test setup, test documentation, and test teardown, and spending 20% of their time actually testing. If you're in that kind of a situation, which piece of that do you think you're gonna get more bang for the buck out of automating? It's the setup and the teardown and the analysis of our tests that oftentimes is a much more manual process than it needs to be, and is a large cost. And so we want to get creative about figuring out how to automate those things, regardless of whether we're doing continuous delivery or not, because a lot of times that's where our cost is in test automation. So in this step, typically, as I mentioned, usually we're doing a much more extensive functional test in a QA/test environment that we hope somewhat mimics production. How much it does will depend on production and what it looks like and what resources we have at our disposal. But the goal is to do our testing at this level on something as close to production as we can get. As mentioned earlier, only after all the quality gates in this step have been achieved do we promote the code on to the next step in the process. Now, after the QA/test environment, where we're doing really, you know, system or integration and system tests, there's often any number of other environments that are set up and tests are run in. Which ones you use is going to depend on your app, and it's going to depend on how you test and what your market is and what your software looks like. Here's some of the common ones that we run into that you've probably heard of. First is staging. Staging is typically a production-like environment. It's used typically for a final system test, perhaps some security red teaming or penetration testing, perhaps some performance and load and performance is done there as well. It's typically something that's as close to production as we can get in terms of how it looks, because the types of testing we're going to do on it are really testing the application within its hardware environment. Sometimes you'll see a separate performance testing environment that includes infrastructure, physical infrastructure, for load balancing and performance monitors and security products and other things that will exist in production that we want to make sure we are testing against. And a decision will be made that that environment needs to be different from staging because some of that stuff is not things we're necessarily going to look at for some of the other types of testing we want to do in staging. Sometimes you'll have a separate acceptance environment. This is often the case in the federal government where there's compliance and final user acceptance and security sign-offs and other things that need to be done by external entities who are going to need to be given access to an environment that's stable, it's consistent, it's there and it's ready for them to do their work on, and it's kind of a last step before we prepare up and package up for production. And then last but not least is something that you often hear as termed as master. And this is really a duplicate environment in which you've got everything all set up ready for your push to production. It is a release. It's not a release candidate anymore. It is the next release, and it's been all set up so that you can hopefully, as much as possible, automatically push it out. The last step in the continuous delivery process is to deploy the fully configured application to its production environment, any hot backups, cold backups, other environments that need to be in place to have the application on it. And this is usually only done after all sign-offs are done on readiness and compliance and quality and security, et cetera, et cetera, et cetera. And as I mentioned earlier, most organizations do not do this automatically. Now, it might be set up as a button, meaning you might have set up a series of scripts that will automatically, pull and configure and update production to utilize the new release of the application that's there for use. But that is a manual push button activity that somebody has to click on based on all the sign-offs and everything, in terms of readiness has been approved. Okay, so we're running out of time here. I want to leave a little bit of time if there's some questions. So some final thoughts here. First of all, as you can probably tell from both the continuous integration and continuous delivery use cases, without strong testing practices and test automation, you're not going to get very far with DevOps. I've often joked that DevOps is the Trojan horse for testing, because so often I've seen, unfortunately, the test organization not being given the resources and the capabilities they need to get the job done. The reality is in DevOps is if you don't do a good job testing and you don't figure out how to automate some of your testing, you're not going to get a lot out of DevOps because you're not going to have much automation in that process. Testing, because of the notion of a quality gate and because of how much benefit we get out of doing that automated work during CI and CD, you really need strong testing practices and processes. If you don't, you're going to push to production stuff that doesn't work a lot faster than you do today, right? So you're just making the problem worse. The second thing is it's wise to start simple. And by that I mean don't try to run out and set up continuous integration, continuous delivery, quality gates, and put all this stuff in place all at once. You'll fail. Start simple. Start with a single step. Usually people start in continuous integration, and they make sure that they are addressing those types of activities, because if you don't do a good job in continuous integration, what you push out as release candidates to continuous delivery aren't going to be very good either. Third is, don't forget that this is an engineering process. It's not a set of tools. So many organizations we see and we're working with today have run out and bought a bunch of tools and pasted them together, and they're wondering why their production code isn't very good. Well, they didn't really think through the process. They didn't think through quality gates. They didn't think through how you leverage automation. They didn't think through all the pieces that are going to make this work and scale. If you're interested in DevOps engineering, there is another webinar coming up in a bit that I'm giving on DevOps engineering. That's a whole separate topic. But if you're interested in this particular topic, as mentioned, June 1st at the ICSQTM conference, be giving a full day on it. I'll dig into all the aspects of the particular types of testing that you need to do, the types of quality gates that you want to get set up. I'll have a demo set up so you can see this in action. We'll look at some tests and how they integrate into things like Jenkins and how Jenkins leverages Selenium and all sorts of fun stuff. So I hope you can make the conference, and thank you all for coming today.